place an ordered pair on the coordinate plane. For example, let's say we wanted to graph the point 2, 3. So we're going to start with our x number. We're going to go over 2 spots, and then we're going to go up 3 spots. So we're going to go over 2 and up 3, and we're going to put a point right exactly where 2 and 3 meet. And we have to label this. So let's say this is point A. So we're going to label our A somewhere right around that point. The dot has to go right where those two cross, however. Okay? So instead of going in the positive direction on X, we're actually going to go in the negative direction. We're going to go 2 backwards. But we're still going to go up 3. 1, 2, 3. So this point right here is our point B. We can also have, let's say, point C is going to be 4, -2. Let's make our y negative. So now we're going to go 4 in the positive direction, but we're going to go down 2. 1, 2, 3, 4 over and down 2, and that is going to be point C. And what happens if they're both negative? -2, -1. We're going to start by going over 2 in the backwards direction, and then we're going to go down 1. And that right there is point D. Most of the graphs that we're going to be looking at are distance time graphs, which means over a span of time, here's what happens. Now, when you're looking at things on a time graph, you always put time on the bottom. And distance, or whatever it is that you're measuring, is going to go on the side, because what you're doing is you're looking at something as time goes on. So for example, in this graph, as time goes on, as time goes on, I increased my distance away from whatever, and then at this point in time, I turned around and I started getting closer and closer to whatever until this time when I arrived back where I started. That's what this graph shows me. Now, this graph shows me that I went the same distance and I came back, but look, I did it faster. There are other distance time graphs that also show you some additional information. For example, in this graph here, somebody walked for a little while, and then they stopped walking. And they stayed there for a while. They sat on a bench, they stood chit-chatting with somebody, they went to the store and did their shopping. Their distance didn't change from where they were, but the time did. So as time went on, their distance stayed the same, and then they started walking back, or driving back, or whatever. So this also shows you, you see how this line is a little bit steeper than this line? So this could be walking to the grocery store, because you walked pretty quick, you did all your shopping, and then you got all these heavy bags you got to carry back, and they carried them back a little bit slower, because this person actually started out way far away, spent the night at Johnny's house, and started walking home, and sat on a park bench for a while, and then finished walking home. Here's somebody who went somewhere. I think in the book this one says, Johnny walked to the movies and sat in the movies, and then started walking home and stopped off for lunch at like Taco Bell or something, and then finished walking home. That's what this story tells. Now notice this one, the distance doesn't stop, but it does change. This one, I think, was throwing a ball up in the air or shooting a rocket up in the air, where it goes pretty quickly up, and then there's kind of this hang time, and it doesn't stop, but it does kind of move a little bit before it starts descending, and it descends very quickly. So this one, there's a little smoother movement at the end. It's not a interesting, I think. So we're going to start out with a basic rule. Our rule here is 2x plus 9, and I've been given x's. I have a 0, I have a 2, and I have a negative 3. These are my x's. So when I work my rule, I want it to look like this. So I'm going to say 2 times 0 plus 9. 2 times 2 plus 9. 2 times negative 3 plus 9. And we write it out like this so that we can see things. Because we don't want to do too much in our head. We're going to do this part in our head. So I want to see all my numbers and then do it in my head. 2 times 0 is 0, plus 9 is 9. 2 times 2 is 4. 4 plus 9 is 13. 2 times negative 3 is negative 6. Negatives, and I might even want to write that negative 6 so I can see it, plus 9 is 3. So now I have my x, I was given my x, I have my y, which is my answer, and I can plot my points. This is going to be x is 0, y is 9. X is 2, y is 13. X is negative 3, y is 3. And now I have my ordered pairs. So we're going to give this another try. And this one we're going to do with an x squared because I want you to see what x squared looks like. So 6 times x squared, 2 times 2 is 4. 6 times 1 squared is 1. Okay, 6 times 0 is 0. 6 times negative 1 squared. 6 times negative 1 times negative 1 is positive 1. Negative 2 times negative 2 is positive 4. So 6 times 4 is 24. 6 times 1 is 6. 6 times 0 is 0. 6 times 1 is 6. 6 times 4 is 24. Ew, weird. We're getting the same numbers here. So each one of these is 2. So my first one is going to be 2, 24. And my second one is 1 and 6. 2, 4, 6. My third one is 0, 0. My fourth one is negative 1, 6. And my second one is negative 2, 24. So it ends up being, it looks like a V. When you get into algebra and these go on. Now, we have N and we have Y. Why this is an X and Y, I honestly don't know. But N right now is the number of the term. So this is the first term, this is the second term, this is the third term. So this is always 1, 2, 3, 4, 5, always. Okay? And our output is still Y. And here is our pattern. And our job is to find the pattern, predict what this one is, but also be able to say, okay, what's the 42nd term? Without adding 42 times, what do we do when we repeatedly add? We multiply. We have to find that magic number so we can multiply to get anywhere in that set, huge set of terms that we want. Okay? So, the question is, what do you do to get to the next number? So, what do I do to get from negative 12 to negative 5? I add 7. And from negative 5 to 2, I add 7. And from 2 to 9, gee, look, I found a pattern. So, what's the next number? The next number is easy enough. The next number is 16 because I've added 7. We're going to find the function. What do I do to get from 2 to 4? I add 2. I add 2. I add 2. Now I know that by repeatedly adding 2, in my function, I'm going to say times 2. Whatever it is, times 2. Whatever n is, times 2. So I'm going to take that adding 2, and I know that that means 2n. My rule here is 2 times n. So, if n is 1, it's 2 times 1, and if n is 2, it's 2 times 2, and 2 times 3, and 2 times 4, just like our function tables. So, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. You see how it's giving me these? What if n is 5? Well, 2 times 5 is 10. What if it doesn't start at 0? What if it starts somewhere in the middle? For example, 7, 11, 15, 19. What do I do to get from 7 to 11? I add 4. 11 to 15 is add 4. So all of these are add 4. But I know that I can't multiply anything by 4 to get 7. That's not going to work. So here. So I know it starts with times 4. So it's going to be 4n. Now, if I need to get from here to the answer of 7, what am I going to have to add or subtract? I know it's 4n because this says 4. So I'm going to start with 4n. So 4 times 1 is 4, but I have to get to 7. That's plus 3. 4 times 2. 4 times 2 is 8. I have to get from 8 to 11. That's plus 3. Whoops, that's not 8, that's 11. 4 times 3, that's 12. Plus 3 is 15. See how this works? 4 times 5 plus 3. They're all the same rule. So my rule is that. So my equation is y equals 4n plus 3. Rules. We're going to work with the rule 2x plus 1. So here we've got our function table with our rule 2x plus 1. So we're going to come up with our x's. We want our x's to be right around here because this is where we're graphing. So we're going to pick the 2, 1, 0. 2 times x minus 1. We need to fill out the rest of our function table. And in looking at this, it makes it a lot easier to figure out what our y's are. 2 times 2 is 4 and 1 is 5. 2 times 1 is 2 and 1 is 3. Now we get to graph them. Our first point is 2, 5. 1, 2 over, and 1, 2, 3, 4, 5 up. Puts the first one right there. And as you can see, if I get out my magic ruler, that this makes a straight line. So this is a linear function because the points that it gives us makes a line. And we can stick absolutely any. Now, what does this look like in a word problem? The word problem is going to walk us through, there's going to be a change, and it's going to be a regular change, and we have to find that regular change and be able to write that down as a rule. So, your turn. The temperature of a liquid increases 3 degrees Celsius per hour. Joe started measuring at 40 degrees Celsius. So your turn, your job is to tell me how does it change, because that's going to be the number before n, and where does it start, and that's going to be your plus or minus. So it increases 3 degrees per hour, that's going to be our 3n. And he started measuring at 40 degrees Celsius. This is our linear function.